So Seb, what are we going to talk about today?
Today we're going to talk about Flutter.
I'm asking because I don't.
You forgot.
Yeah.
In the 5 minutes coming in. Yes.
Okay.
So today we're going to be talking about scrolling in Flutter and how it works. I am Sebastiano. I am an Android Flutter and Identity GDE, work at Nevada, London.
GDE of life. Eugenio, I work at Clue in Berlin, GDE in Flutter, Kotlin, and Android.
The overlap.
Yeah, I'm curious.
Yes. Cool. So first of all, before we start, a little disclaimer. There's going to be a lot of stuff. And for all of you that are here, if you feel lost, it's fine. Go and watch the recording when it's out. And we're going to upload the slides anyway very shortly after the talk. And then, yeah, that should be it. Just to prove that we're not messing around, we're just going to fast forward to the end of the presentation. Yes. Okay, cool. So,
and this is how it all comes together. Applause. Thank you, thank you.
And this is all for today. Thank you very much. That's it.
Great. Yeah.
Cool. So, now that we've done that, obviously that slide is a lot of stuff, maybe a bit too much, possibly. Hopefully by the end of the talk, all that stuff will be a bit clearer. But let's take a step back and let's talk about scrolling. So, at the very beginning, what is scrolling? We all know what it is. And there's some very obvious key facts. I don't know if any of you here is an Android developer. We are Android developers, as you might have assumed from the titles. But I'm not entirely sure how it works on iOS, but I think it's kind of hard there as well. But there's a few things that everyone knows, at least on Android, when it comes to scrolling containers. They are everywhere, because all the apps have scrolling bits, and they're hard. Actually, they're not hard. They are very hard. But why? What is it that makes scrolling so hard? Well, scrolling is, like many other things in user interaction, is a physical metaphor, which means users will have expectations. So everyone is used in real life to get something and just push it with their hand or something like that. So they will expect that your app will behave the same way.
And like reality doesn't lag generally.
Yes, sometimes.
You took substances.
But we're in the matrix, so yeah. Yes. Also, there are effects. When you are on iOS, for example, and you overscroll, you expect things to be overscrolled and go beyond what the limit of the list is and then bounce back. Whereas when you are on Android, you will have the edge effect and so on and so forth. There's also interaction patterns that are hard to do. For example, you might have scroll bars, you might have pull to refresh.
All the various up bar craziness, coming back,
yes.
etc.
Sticky up bars and all those things. And if that was not enough, there's multimodal navigation, which means lists must be navigable with your fingers, with screen readers, with mouse and keyboard, with a D-pad, all those things. And then I mentioned screen readers. Navigation is strictly tied to accessibility. A list is accessible when it is also navigable. So yeah, there's a lot of things that come together. But there is not the only thing, really, because there's one very big problem that concerns scrolling, which is that performance is hard. It's very hard. And making it work nicely is not automatic. There's a lot of effort that goes into it, especially if it was not built in from the beginning. There's another thing that is very hard to do, and that is not naming, no.
Sorry, can I add one thing?
Yes.
You know when like you should not preemptively optimize stuff because you're probably not in a hot path, it's not a problem, like you're just overthinking it. In scrolling, it's the opposite. You need to optimize no matter what. You're going to do the hardest thing there is, which is UI, and you're going to do that like 60 frames a second, which is a lot. So it's like the worst possible thing you can ever do, pretty much.
Yes. So as I was saying, there's another very hard thing besides naming that, as we all know, is very hard, And that thing is abstractions. And in particular, it's very hard to build abstractions around scrolling. And it's almost impossible, it seems, from the track record of the software out there, to build good abstractions around scrolling. Why is that? So if we look at what we have on Android, for example, we have two main abstractions around scrolling that are two very specific and very special cases. One is list view, and the other one is recycler view. List view is the old, venerable scrolling container. It is easy to use. It covers the main use cases. But because of its ease of use, it shields people away from the actual machinery, which makes it really hard to customize, because every time you try to do something that list view is not agreeing with, you're going to be fighting with it for control. On the other end of the spectrum, on Android, there's recycler view, which is actually the only other real scrolling container we have except for scroll view. Now, recycler view is the opposite. Recycler view is way more customizable, is way more lower level, and people can just plug things into it, well, to a certain extent anyway, but that makes it very much harder to use. So things that would be very easy and straightforward with a list view, like the basic cases, there's a lot more overhead that you have to go through and a lot more boilerplate on a recycler view.
And in both cases, they're like these giant pieces of code that are really like hard to read. If you ever need to modify something that was not meant to modify, oh God, don't do that. No. So yeah, it's hard.
So what about Flutter? First of all, we need to take a short detour. We have done a talk last month that was about how Flutter draws stuff on screen. This is the condensed version of the whole talk in one slide, probably. The main bits anyway. So how does UI work on Flutter? First of all, you deal with widgets. When you are developing an application, you're declaring your user interface with widgets. Widgets, over time, through the build method, are updated. So you have three states of the widget up there.
Well,
yes.
Yeah, no, technically they're recreated.
Yes.
Just
yes. He's a nitpicker. When you have widgets, all your various instances of the same widget talk to the same element. An element is basically a sort of an adapter between a widget and what lies beneath. What lies beneath is the render object. A render object is kind of like a view is in Android. Not exactly the same thing, but is a long-lived, stateful item that can be mutated, whereas widgets are immutable.
Render objects are very heavy, so you don't want to recreate them often. You don't want to change properties on them often, because that's going to cause relayout, redrawing, etc. While widgets, you can destroy them and recreate them as much as you want. It's very, very cheap. So
the good news is that you don't have to care about that, because Flutter does it for you. So you're not going to see that unless you go and touch stuff, which you can, but you don't need to. And lastly, render objects go and render things on screen. So they're basically the last bit before you go into drawing land. So that's the end of our short detour. Now, let's go back to scrolling in Flutter. Scrolling used to be different. A couple of years ago, there was a thing that was called, and I kid you not, the Great Refactor. That was, in 2016. Which is when they introduced list view. Now, we're going to talk about list view later, but you're going to see that it's quite a frequently used component. It's not exactly the same as the Android component with the same name, though. In Flutter, scrolling is a normal thing. It's not a special case. It's not a thing that only some views are able to do, because it is a framework thing, and it is like everything in Flutter, it can be composed into other widgets that you're using. So it is not like a special citizen. There are some very solid abstractions around scrolling, which makes it easier to understand to a certain extent and makes it very flexible on another. And that part might not be as easy to understand because it is very abstract.
The idea is that you should not like hold all of it in your head. Instead, like you just think about the small pieces. Those are easy to work with, and then when you compose all of it together, it should work. Yeah. Sorry, another thing. I wanted to say about the layout. Like, it's incredible the fact that scrolling is just doing the layout multiple times. This is crazy. That being said, there's a lot of other stuff that you want to do for doing proper scrolling. So as we said before, all the metaphors, all the input, deciding what to do. So that is still a huge thing, and that's why this framework is still so complicated, despite having the layout part mostly figured out. So yeah.
Scrolling is very self-contained. It is a thing of its own. And there is no special machinery. It's just a thing that you can use whenever and wherever you want. Now, it is still very complicated. It doesn't become simple just because the abstraction is nice. But you don't need to touch it. You don't need to see how it works, unless you're a crazy elf like this guy here. Yes, you. There are several...
I won't let you touch the slides anymore.
Yeah, whatever. There are several kinds of scrolling widgets in Flutter. One is list view. The other one is refresh indicator. Then there is page view, and then there is custom scroll view. Now, what is a list view? Well, it's quite obviously what you would expect. It's a thing that shows a list of stuff, and that's pretty much all there is to it.
Fun fact, you can write your own list view in like 10 lines of code or something.
Then there is refresh indicator, which is the pull to refresh thing that we're all used to. There is page view, which is what on Android you would call a view pager, which is basically a widget that you can page through several items, the stuff that you get like in onboardings and things like that. And lastly, there is a custom scroll view. Custom scroll view is basically a fancy list view that allows you to have different, like nesting different kinds of items, different kinds of scrolling direction, layouts, and so on and so forth.
And yes, list view is just built on top of that.
It's a simplified version.
Yeah, just wraps it
pretty much. Now, what is in a scroll? Well, there is, when you take a scrolling container, like such as this one, and there are three main parts to it. The first one is the interaction. The second one is the container itself, and the third one is the content. Now, the interaction is the scrolling itself, so that's what you would expect pretty much. The container is a specific widget that is called Viewport, that is a viewport, pretty much what the name says. And lastly, there is a big thing that he's going to be talking about later, which are slivers, which are the contents.
Yeah, I just want to say, in the usual Flutter tradition, everything is very well abstracted and separated to the point where like the scrolling layer knows nothing about the other layers. It's like pure scrolling logic without any idea of how to render anything. Viewport and slivers sort of work together, and the point is that slivers, as we'll see, are an abstraction to make all scrolling effects a lot easier to implement, but they live in a sort of a different dimension, different from what you normally do. And so in order to be able to interact with this weird dimension, you need something like a viewport. So a viewport is like an adapter between the normal kind of widgets you would have and the sliver ones.
Yes. Now, we're going to be looking briefly at all three of those areas, components, let's call them. The first one we're going to start with is the middle one, is the container, because that's the easy part. A container is, well, we mentioned this name, which is viewport. What is exactly a viewport? Well, a viewport is a special widget that, quoting the documentation, is bigger on the inside. I am seriously quoting the documentation. Someone is a very big Doctor Who fan over at Google.
They told me, well, it's true.
Yeah, I guess. Now, viewports are a widget that is able to display children as specific offsets. And all these children are slivers. We're going to see slivers later. Yes, I must have messed up something there. Sorry. When you have slivers inside, well, let's call them children for now, inside of a viewport, what the viewport does is to decide where to put stuff and how to show it, it has to pick a center item. Now, the center item becomes the anchor for the whole layout. Basically, you say, okay, I'm going to take this item here, and I'm going to make it so that it shows at this specific point, and everything else is laid out relative to this one. In this example is the first one, but it doesn't have to be. It can be the second one. It can be the last one. It can be anything. It's very abstracted away. Now, when you are in a viewport, you are doing something that scrolls. Obviously, scrolling needs a direction. So a viewport has a scrolling axis. Now, yes?
Yeah, we should also say what that means. Like, normally scrolling is, thought to be just vertical. And whenever you need to do horizontal scrolling, that's an exception, and there's like a different component to do it.
That's on Android.
Yeah, in general. Not here. You just literally flip a flag, and suddenly the direction is not vertical anymore, but it's horizontal, because why not?
Abstractions. So once you pick the scrolling axis, and then you have defined what is the center sliver, and at that point, you have an absolute position of the center sliver inside of the viewport. That position is obviously relative, and it's, well, I say absolute and then relative, but yes, it is relative to the extent of the viewport and goes from 0 to 1.
It's absolutely relative.
Yes, absolutely maybe. The default configuration for a viewport, what you get out of the box when you just throw a viewport in your layout, is that you have the first child is the center item. Then the axis direction is vertical and precisely going down. And we'll see what that means later. And then the anchor, which is, in this case, the top edge of the center item, is positioned at the coordinate 0. So just to be a bit more specific, the anchor is the edge of the center item that is in the opposite side of the scrolling direction. So basically, the scrolling direction is down, then you take the top. If it's up, then you take the bottom, and so on and so forth. Now, there's two kinds of viewports. There is the good old normal viewport, which, if left to its own devices, will just take up all the space that it can, which is kind of like, if you're on Android, sort of like match parent. And then there's the so-called shrink wrapping viewport, which is a viewport that only takes as much space as it needs. This is useful if you need to have a list of items that can be smaller than the whole screen. So you can, for example, you can put stuff underneath that and have it showing. Obviously, the normal viewport that doesn't need to check the height of the items every single time is more performant. So you shouldn't use the shrink wrapping one unless you really need to. Now, interaction is the next bit, which is the part that users see.
We should say this is an entire talk on its own.
Yes,
And
we have just
really
summed it up a lot.
Yeah.
So there is a widget. Surprise, this is Flutter, everything is a widget. The widget is called Scrollable, as you might expect. And it scrolls, obviously. that's what a scrollable does.
So if you think he's kidding, that's literally the definition.
I like to think that when they wrote the documentation, they were very ironic about it. I don't know it for sure, but that's the only possible explanation for this. I don't know. I have no data to back this, but possibly. And then the scrollable also handles gestures, which means it takes all the touch input or the keyboard events or whatever, and it does the actual scrolling. So it says, oh, something is happening. Oh, I need to move the items or something along those lines.
Yeah, just like imagine this like huge like piece of glue that keeps together the logic with the touch events, with everything else. It doesn't necessarily implement the logic directly. It delegates it to other things, but it's what keeps all of it together. So if you ever want to change at a fundamental level how you go from touching something to computing what that touch means, you would change this, which would probably not happen because I don't see how.
That would make for a very weird thing. Basically, there are three main bits that enter inside of a scrollable. There is a viewport builder, which is you can kind of think of as a thing that takes build context and a scroll offset and gives you a widget. There is the physics, which is the physics of the scrolling, so inertia and all those things. You can have like moon physics by just swapping that out if you want. And then the last bit is the controller. The controller is, let's say, the thing that kind of gets information from all the other bits and decides what to do with them. Am I correct? Yes. Good. Now you get all three of those and you pass them inside of a scrollable. And that's how you build a scrolling container in Flutter. That's very easy. That's all there is to it. Well, that you have to do anyway. Now, there are three main kinds of scrollables. The first one is scroll view, which is not exactly the same thing as the ones that you have on Android. If you are an Android developer, not the same thing. A scroll view is basically a thing that contains stuff that scrolls. That's very generic. The scroll view you have on Android, instead, is much more similar to the single child scroll view. Why is that? Because the single child scroll view, as the name implies, does exactly the same thing as the Android scroll view does, which is I take a child, it is probably bigger than me, and I'm going to make it scrollable. And that's all it does. And then the last one, main, let's call it subclass of scrollable, is page view, which we've seen already. It's just the paging view.
Yeah. So what I want to say about the scroll view, because I didn't understand the difference between scroll view and scrollable at the beginning, but then I realized scrollable is the abstraction that doesn't know anything about rendering, doesn't know anything about viewport and slivers, and it needs these three ingredients to do its job, right? Scroll view provides them. So scroll view is the actual, let's say, implementation detail that says, this is the complete package already done. You can use it however you want by customizing, etc. But that's the main difference between the two. And in fact, the majority of the scrolling classes, they extend scroll view because it's already ready for everything.
You like to talk? There you go.
No?
Yes.
Oh, we already, yeah?
Yes.
So, this one, right? Yes. All right, so let's get to the saucy bit, or the esoteric one, however you wish. So, Flutter is very interesting. I've never seen a framework like this, and especially when it comes to scrolling, because they approach the problem of scrolling in a completely different way than any other framework. Before we proceed, and I can show you how that actually works, I want to explain how it normally works. Like when render objects do the layout, what happens in that case? So render object is a very low abstraction. It's so low that it actually doesn't even have an opinion on the coordinate system you should use. I mean, sure, in the end, you're going to paint something on a canvas, and that has its own internal coordinate system, right? But as far as layout goes and all that revolves around it, it does not have an opinion. In fact, there is renderbox, which extends a render object, and it introduces the opinion of a coordinate system, which is the classic 2D Cartesian system, pretty much. And then it builds a lot of abstractions over that, helping you to deal with this sort of normal constraints. It's basically a box with a size, essentially. And the way render objects work is that they are sort of like input and output. You get some constraints as input that the parent does, and then it gives them to the children, and the children decide as an output something, and that goes through all the tree, essentially. And then the parents decide, once they know what the child would want to be, how to display and lay out every single child. So yeah, the coordinate system here is the classic X, Y, etc. Actually, no, not true. It's not even X and Y. It's more based on the dimension of the boxes that you want to do. Let's take an example. This is one of the classic constraints you get. So you get a maximum width of your box. Then you get a maximum height, right? And you get a minimum width and a minimum height. Once that's done, you know exactly the range in which you can be. And so you just have to pick one, and you return a size, which is just width and height. That's it. You have no idea where you're going to be placed or anything like that. In fact, at some point, the parent will take it from there and say, OK, I think you should stay here. And that's it. So this is easy. It's like 2 dimensions, like width and height. Very easy to reason with. It's spatial, you know, like it's easy to take this and port it to reality and have a concrete example of what you're dealing with. It's different with slivers. So this is the end of the day tour. So, OK, let's. I want you to completely forget what you know about drawing UI and about you know, the physical world. Imagine you're in a different dimension where the rules of physics just don't apply, okay? Because the sort of questions you need to answer are different than the classic, how big is this? It's not as easy as how big is this, because the size is relative in this world. And that's why you need a viewport to display slivers, because they normally talk a protocol, which is very different from the render box protocol, right? Slivers are a sort of an in-between abstraction between your root, the viewport, and the content that you want to scroll. Why not just put the normal boxes inside and use that, right? The problem with that is that the normal boxes have no idea of the fact that they are in a scrolling container, and they don't allow to do things like infinite scrolling lists, or the AppR tricks that we mentioned, or having sticky headers. Like a box that knows nothing about that, and that's why it's not a good representation of it.
That is what Android does, and you know how painful that is. Like having normal views in a scrollable container makes it very hard to do a lot of things. So they just decided not to do that.
But it's mostly because if you decide to keep the old coordinate system and do decisions based on that, you still have to convert to this weird internal coordinate system of the slivers, but just in your head. And then you write code that is based on the old thing. What they did instead was to nail down, like put as code the actual abstraction and then work into that space, which is very smart. So they are slices of content. This is like the formal definition of what they say, and this is what the word means. Oh, no.
Yeah. They are not the Android P slices, completely different thing.
That's why the microphone was off. Anyway, and so it all starts from this render sliver, which extends render object. It's like the equivalent of render box. And there's a lot of customization going on, but mostly, of course, this is in the render object layer. You normally work with widgets, and in order to work with widgets, you need something that wraps them so that you don't have to deal with them directly. It might happen sometimes that you handle with them, but in general, that should not be the case. So let's see more or less what we're talking about. Let's start, and the part of the cross, yeah, whatever. So before anything, imagine that the sliver world is like monodimensional in many ways. Like, as far as space goes, it's not 2D, it's 1D. It's one line, okay, that can be infinite. But that being said, although you have this main axis, there is also a cross axis. But you don't really use it. It's more of a hint towards the children in case they need to do something with that. So what you get, of course, is this, you get the size of both, and we'll see now. But mostly now we're interested about the directions, because as we said before, your main axis can be vertical or it can be horizontal, but that's not all the story. So imagine you have a direction down, okay? This is the standard direction, and this is what we're gonna use in the example. There's a different kind of direction called the growth direction. The growth direction is given your 0 point, right, your origin, how do the children grow in respect to that? And as you can imagine, the normal way, the one on the right, is a forward growth direction. You can also invert that, and your children will be completely flipped upside down. But notice how we still take the top edge of the children since we are going down. If we were to go in the opposite direction, it would be the bottom. Apart from that, there's also a different kind of direction called the user scroll direction. Now, this is another brilliant bit. The user scroll direction is not just the scrolling direction. This is literally what the user is doing, which means that if you are scrolling because of an animation, that will not be counted. So you know exactly the difference between an actual user input and something else, which is great. And something that's missing on Android, for example. So sometimes it's hard to disambiguate between programmatic.
Yeah, you can do animation scrolling on Android, but it's basically pretending that the user is flanked on the view, which is not very robust in any way.
You can still get the normal scrolling events, like if you need to sync somehow with the scrolling container, that's fine, you can do that. It's actually something that bubbles up the widget tree. So you don't even have to be inside any of this. You can just stay outside, watch for scrolling notifications bubbling up, and then you do whatever you need to. In fact, the pull to refresh, it actually doesn't use any of this. It just listens, and that's pretty much it, right? Yeah. So scrolling it has 3 states. It starts as idle, which means the user is either not touching the screen, or they have the finger down, but they haven't dragged yet.
Which is very hard to do, because scrolling by 0.
Try me.
Yeah.
Yeah. I mean, let's say you have not gone over the threshold that is considered scrolling. The moment you do, though, then you start going into a direction. Now, it's a tiny bit confusing because the direction is like the opposite of the growth direction, depending on the axis. But so in general, think about it this way. So imagine you are going forward. So let's look at the one on the right? Growth direction is forward. If the user scroll direction is forward, it means you are pushing up your things. If you are pulling them down, then it's reverse, because it's following the order of the list. If we go forward in the ordering of the list, then it's forward. If you're pushing it back, then it's reverse. That's more or less the idea. But so you get to know all of this, and then you can decide what to do. The other thing you can do, and
at the end it goes back to idle.
Yeah. When you lift the finger, it goes back. The other thing you can do is knowing about, as we said before, the dimensions of the viewport, because why not? So there's 2 dimensions, of course, cross-axis extent and the main viewport axis extent, right? You were told these dimensions, but you should not rely, like, a viewport could be infinite. In fact, the shrink wrapping viewport, the way it knows how big the children want to be is that it gives no limit. It just says, I am infinite, be as big as you want, and then I'll try to lay myself out based on that. So, just so you know. The other thing, super important, is the remaining paint extent. Now, the way slivers work is the key here. Slivers are children. They are laid out, let's say, every time. Even if they're invisible, they're still laid out. And in fact, you normally don't have many slivers. It's more like the slivers themselves have children, which can be an infinite number. So the things that you normally draw on screen are not the slivers directly. The slivers are just a container that deals with all the effects, let's say, right? How do they know how much to draw? Well, this is how. you are given an amount of this resource, let's call it, which is the paint extent. There's one paint extent for the whole viewport, and every child in turn is given the chance to consume it. When it reaches 0, you're done. You're still going to get called, but you're not supposed to say that you're going to draw anything, okay? And the point is also very interesting that every sliver is called with not the global thing, but whatever is important to that particular child. So if you are the second child, you're going to have a smaller paint extent, and so on and so forth. This also ties in with the whole system of how slivers work. So when you are a sliver, you tell multiple things, essentially. So you can say how much scrolling space you want to occupy, which means how much does the user have to scroll before you're going away. That's one thing you can say. The other thing you can say is, let's say physically on the viewport, how much space are you going to have right now? Which is a measure that is like, once you're at the bottom, let's say you're scrolling up, right? You are at the bottom, invisible. Your layout extent will be 0. The moment you start going in, it starts becoming positive, and then it becomes, let's say, the full height that you can have. And then the moment you go over the edge, it starts going down again, and then it becomes 0 again. That's how you declare how much space you're occupying. Normal slivers, the one you can imagine, just do it like the way I just described it to you. But you don't have to do it that way. You can have a sliver that does not occupy any physical space, because it's always 0, but it can still influence other things. So the third dimension you give back as a sliver is the paint extent. And so you can essentially say, how much do I want to paint of this resource? The beauty of it is that once you scroll past the edge, even though you might have a layout extent of 0, you can still paint. And that's how they do the up bar, for example. The up bar is already scrolled over, but it still returns a paint extent, although normally it would be 0, right? And because of that, you're given a piece that can be drawn even over other slivers.
Yeah, I think a very important difference if you're used to Android, where you would have the up bar that sits in an up bar layout, that sits in a constraint, not a constraint layout, a coordinated layout. I always mix them. Then the up bar is not inside of the scrolling thing. So the scrolling thing needs to have this behavior attached to it that says, oh, I'm scrolling. And then the coordinator layout takes the scrolling and then applies it to other views. But in this case, in Flutter, if you want to have like an up bar that does quick return, the up bar would be a sliver in the list and would sit in the list. So that's a very important difference.
In a way, you could think about slivers as a hybrid between the coordinator layout and a recycler view, all in one package.
Yes.
But that works. The other thing you can know is, because, as we said, someone can paint over you, then you can know that. If someone before you actually painted over that section, you can decide based on that that maybe you want to shift yourself, like have a longer layout extent so that your paint will not go over that, for example. You can do all sorts of crazy tricks. Another thing, yeah, this is the most confusing one, but it has a purpose, okay? So it's called scroll offset. And you're going to think, oh, that's easy. I mean, it goes from 0 to whatever, right? Nah. So this is how it works. I'm just going to show you because it's easier. The idea is, so in this example, the scrolling axis is down, okay? Because otherwise, it's always based on the edge of whatever scrolling is. So if the scrolling direction is down, the edge at the top is 0, okay? Your scrolling offset is 0 always, except when you start going over the edge. And this is because when you start going over the edge, you need to know how far, let's say, you are, in order to know how much you still want to paint. And so that when you go over the edge, you can say, well, I'm very far, so I won't be able to paint maybe inside the viewport, but maybe I can do something else. Maybe I can still push everything, or whatever effect you want to achieve. This is doable. And the whole system is very biased against the border. In fact, if you want to do something like draw over other slivers, but you are before in the list, then, for example, you can't. Because you can only start doing like the upper stuff once you're over the edge, right? Unless you wrap other slivers, but that's a different thing. So this is more or less how it works. And keeping in mind that the scroll offset is given by one of those values we return, which is the scroll extent, which is different from the layout extent, because like the scroll extent, in a way, it's like the global physical measure of how much you can scroll. The layout extent is actually how much space you're gonna, let's say, push your siblings down, pretty much, which they often are the same eventually, but they can also not be, and by doing that, you can achieve all sorts of crazy effects. Yeah, so in the end, what we want to do is to return this scroll extent, and then this paint extent, which also has an origin, so you can shift your paint and even paint before or after yourself, which is great, and that's how the upper also works. And layout extent, which again is how much, let's say, physical space you have in the thing. But in many ways, it's almost like slivers don't exist physically until they start getting into the viewport, and then suddenly they are, inflated into this thing that exists, and then they sort of go back. But when they are in these 2 dimensions, over the edge on one side and over the edge on the other side, they can still influence whatever is happening in the viewport, and that is the secret, pretty much, to all of this. There's a lot of things I'm not saying, like this is an oversimplification. There's like a cache that can help you with, like, when you're drawing, the system knows you're gonna get there eventually, and so you can pre-draw more than you have to, so that the next frame you're not even gonna get called, for example. You can say a few optimizations, like, am I visible, yes or no, despite the fact that I might be painting or not, etc. And then the other very powerful thing is that if you want, although it is expensive, you can return a scroll offset correction, which means the moment that happens, everything's going to stop, and the layout is going to run again with the scroll offset correction applied to the entire thing. And so every child can also influence the entire scrolling itself, which is great. So yeah, so with this you can achieve sticky headers, upper stuff. You know that annoying thing where, like on websites, you start scrolling, at some point you keep scrolling, but the content is stuck there, and maybe there's an animation running inside that responds to your scroll. Have you ever seen that? Or like advertisements tend to do that lately.
Yeah, there's a lot of like interactive things on like the New York Times. They're very nice, they're not annoying.
Yeah. And so the way you would do that is that you would return a layout extent of, always maybe the whole viewport or maybe not, but the scroll keeps going. So you're consuming scroll, but your layout is always the same until a point where you say, okay, I had enough, and then little by little, you just let go of your layout extent, and other things have the chance to go in, essentially. So it's interesting. Yeah, and so this is how it all comes together. We have to avoid the paradox because we announced at the beginning, so we had to do this slide. So
yes.
Applause. Yay.
That is all. We hopefully haven't tired you too much. Yeah. I know it's the last slot of the day, and this is a very dense talk. So, yes. Thank you very much for coming.
Where can they find us if they want to consult us?
If you click, it goes to the next slide, and they can see that.
These slides are so perfect. Yeah, so this is us, Twitter and stuff, and you'll find the slides there in
whatever time.
In time.
By tomorrow.
Yeah, but you can save the link if you want to, and
yes.
Eventually you'll
We're going to be
find
tweeting the link anyway,
exactly.
So it's easier to follow us and see that than the other way around. Yeah, okay. Free followers.
Yes. Yeah. Thank you very much.
Thank you.